Now I'll explain you how to use analog input and output blocks. As you know, in case of a discrete block, the state of the input or output would always be either 1 or 0. But in case of analog input or output block, the state of the block or the parameter associated with the block will be of the nature continuous, means it is varying continuously. That's the reason it is called as analog input or analog output block. In case of analog input block, in real situation or in any process control application, the information to analog input block will come from transmitters, more precisely from temperature transmitters. If the temperature of the furnace is varying, according to the variation in the temperature, the output of the transmitter will get changed, which is in the form of 4 to 20 milliampere, and that 4 to 20 milliampere will be fed to the analog input card of a distributed control system, and that input would be connected in a soft manner to this analog input card. So if I want to use analog input block, I have to drag and drop that block like this. And if I want to configure an analog output block, I have to drag like this. Analog output cards are basically blocks which are sending actions generated by the controllers to the field devices, and that's the reason they are called as analog outputs. Analog outputs are always in the continuous form, and the output is 4 to 20 milliampere. And the devices which are connected to analog output card are like a modulating solenoid valve using I2P converter, or a variable frequency drive which will receive a signal from this analog output card to change the speed of the motor connected to VFD. Now this is how analog input and output cards are being used. One more particular point which we have to keep it in mind is these analog input and output cards, when they are in the hardware form, they will accept input in the form of 4 to 20 milliampere and deliver output in the form of 4 to 20 milliampere. But while processing all those inputs and outputs to make distributed control system generic in nature, irrespective of the range of the transmitter, the calculation should remain same, and that's the reason these blocks are always in the normalized form. And the meaning of the word normalized means all the range or 4 to 20 milliampere will be converted in the form of 0 to 100%, which becomes easy for processing. Now let me put this analog input block and connect it. So click here and find out this ground which is glowing and release it. You can configure this block by saying select tag number. If you are connecting this entire system or you are using this compiler for remote trigger laboratory, you will be getting the tag name from the field or from the P&I diagram. At this stage, the mapping address would be auto-generated. You don't have to do anything. You can add a description of the analog input card. For example, I want to put the description as temperature transmitter number 1, so that is TT underscore 01, which would be same as the tag name of the actual field instrument. If I submit this and if I go and click onto the block or just scroll on the block, the tag name will be visual. Similarly, I can configure analog output block wherein I will write flow control FCV underscore 01 is the block which I have kept. As I am not using this for remote triggered laboratory, this is for simulation. So here the tag name would remain as none. If you click here, only none tag name would be available. Because this is for simulation, submit this. When you have completed the logic development and configured analog input and the output block, then compile. If the compiling is successful, then and only then run tab will become blue, If not, run tab will remain gray. If you click on to run, the compile, run and clear tab will become gray, indicating that now this circuit or the function block diagram is in run mode. And if you want to stop it, you can click on stop. But if you want to send some analog input to the analog output block, you can right click on this, edit will come, and then edit the value. Now this value would be in the form of 0 to 100%. So if I have given value as 50%, and if I submit, this value will get transferred to analog output block. In turn, this block is connected to a control valve. In other words, now the control valve is 50% open or closed depending on the action of a control valve. If you still want to change, again edit, can give a value, for example 100. Now the same value will get changed. Now this is how the circuit or the logic can be tested using function block diagrams. If you want to stop this, you can stop. It will go to its original position, saying that value is 0. And now if you want to add one more circuit, you can add now. Or if you want to clear this entire circuit and read on new circuit, go to clear, ask for, do you want to clear this workspace, say yes, and this entire workspace is now available for you to write the new logic. Thank you.